Algebra 2 Honors Lesson 1-5, solving absolute value equations. Alright, here are the lesson's objectives. Alright, now a few key vocabulary, alright, for the lesson. The first one is extraneous solution. Alright, just think of an extraneous solution. Alright, it's a solution that doesn't work. Alright, and because it doesn't work, it can't be considered, alright, one of the possible solutions. Okay, so just keep that in mind. An extraneous solution, alright, it's an answer that we come up with, but then in turn, when we check it, it doesn't work in the equation, so it can't be considered a solution. Alright. And absolute value inequalities, which is the main topic of the lesson. Alright, just remember, if you have a variable inside absolute value symbols, alright, and then the inequality symbol, alright, so if it's greater than or equal to, alright, just some numbers, just remember, if it's greater than or equal to, alright, the problem is going to be a disjunction. Alright, if the absolute value is less than or equal to, alright, some number, alright, it's going to be a conjunction. Okay, just remember, absolute value greater than or equal to, disjunction. Absolute value less than or equal to, conjunction. Alright, so the first thing, let's solve a couple here. Now, if you have an absolute value, alright, problem like this, alright, where the variable is inside the absolute value bars, you need to split it up into two problems. Alright, so the first one is the exact same thing, but without the absolute value bars. Okay, but without the absolute value bars. Alright, now the second one, alright, is going to be what's inside here stays the same, right? And then you're going to make the 12 negative, right? And then just solve each separately. So you're going to add 4, 2y is equal to 16, divide by 2, y is equal to 8, right? Add 4, 2y is equal to negative 8, divided by 2 is negative 4. So your two solutions, if you were to graph them, basically just show where 0 is at, negative 4, let's just estimate about there, 8 is about, let's say, right here. So if you're going to graph these two, all you're going to do is you're going to make a bubble at negative 4, color it in, a bubble at 8, color it in, and that's it. Right? You don't go right or left because obviously there's no inequality symbol. Alright, there's no greater than or less than, so you don't know which way to go, right or left. So you just color it in, because what that means is you're only counting this point. We're only counting 8. We're only counting negative 4. Okay? Alright, if you have a multi-step absolute value problem, like a problem like this, now you notice you can't split this up into two separate problems yet until the absolute value part is by itself. So you always have to make sure this is by itself first before you split it up. So let's get this by itself first. So we're going to add 5 on both sides. 3 absolute value 4w minus 1 is equal to 15. Now divide by 3 to divide out to 3. These eliminate. We have 4w minus 1. Alright, absolute value is equal to 5. Now that this is by itself, now we can split them up into our two problems. So what's our first problem? It's the exact same thing, right? Without the absolute value bars. Then the second one, right, whatever's inside here stays the same. Right, 4w minus 1 is equal to negative 5. Negative 5. Right? And then just work it out, add 1. 4w is equal to 6, divide by 4. Right? W is equal to 6 over 4, which reduces to 3 over 2. Over here, add 1. 4w is equal to negative 4, divide by 4. W is equal to negative 1. So now when we graph this, we've got, say, 0 here, -1, +1, and 2. So when we graph this, well, 3 over 2 is a mixed number, or is in proper fashion. What you want to do is change it to a mixed number. So change it to a mixed number is the same thing as 1.5. So where's 1.5? Approximately right there. Color it in. And then we're also at -1. Color it in. And that's it. That's what the graph will look like if you had to graph your answer. Okay? So just make sure the absolute value part is by itself first before you split them up into your two problems. Okay? Extraneous solutions. Okay? Alright, the absolute value part right here, okay, it's by itself. So what we're going to do now is, alright, we can split them up. So the first one is the exact same thing. 2x plus 5, right, is equal to, right, 3x plus 4. So that's our first one. Or, now remember what's inside the absolute value stays the same. 2x plus 5 is equal to, and remember we had to change everything over here to the opposite, alright, to the opposite. So if it was 3x, it's become negative 3x, and if it was 4, it's going to become negative 4. Alright, and then let's work it out. So we minus 3x, we negative x minus 5 over here is equal to -1. So x is going to equal 1. Right? We divide by a -1. Over here, if we add 3x, we're going to get 5x plus 5 is equal to -4 minus 5. 5x is equal to -9 divided by 5. Alright, so x is equal to -9 over 5. Alright, now we're going to check for extraneous solutions. Right, in order to do the check, what we're going to do is, if we think this is an answer, you have to plug it back into the original problem and see if the left side equals the right side. For example, right here, 1, we're going to plug it in right here. So we're in the absolute value of 2 times 1 plus 5. Does that equal 3 times 1 plus 4? Okay. So 3 times 1 is 3 plus 4 gives you 7. Over here, 2 times 1 is 1, right? Plus 5, that gives you 7. What's the absolute value of 7? 7. Alright. So we know this is a solution. This works. Over here, if we plug this in, alright, 2, alright, times -9 over 5 plus 5, alright, does that equal -3, right, times -9 over 5 minus 4? Okay, so we're going to do all the work and see if it works out. Alright, so we're going to get -18 over 5 plus 5 is equal to 27 over 5 minus 4. Right? Now, the easiest way to do this when you have fractions, right? Let's get rid of the fractions. To get rid of the fractions, what are we going to do? Multiply by the common denominator. Well, this is easy since 5 is the same here. If we multiply everything by 5, it'll get rid of the fraction for us, right? And make the problem a lot easier. So these are going to eliminate. So you're going to end up with -18 here. Alright, 5 times 5 is 25. These eliminate, so you get 27. Alright, minus 20. Alright, it's a lot easier now. We got rid of the fractions, we're good to go. So let's work this out right here. What does this give us right here? This gives us 7. Alright, 27 minus 20, that gives you what? 7. Alright, so this one also works. Alright, so -9 over 5 also works. Alright, so since they both work, alright, there are no extraneous solutions. Our absolute value inequality problems. Alright, 3x plus 6, our absolute value is greater than or equal to 12. Now, first of all, since it's inequality, remember it was greater than, it's going to be an OR problem or a disjunction. So since this is by itself, let's split it up. So we get 3x plus 6 is greater than or equal to 12. So the first one's the exact same thing without the bars. Or, alright, now whatever's inside here stays the same. 3x plus 6. Alright, flip the arrow. Is less than or equal to now, and make the 12 negative. And then work them out separately. Minus 6. 3x is greater than or equal to 6. Divide by 3. X is going to be greater than or equal to 2. Right. Over here, minus 6. 3x less than or equal to negative 18. Divide by 3. X less than or equal to negative 6. And then if we're to graph this, so we're negative 6 and 2, so let's say here's 0, negative 6 over here, so 2 is about over here. Right. So we're going to have a bubble at negative 6. Right, there's a line underneath, so we color it in. Right. Over at 2, there's a bubble, a line underneath, we color it in. Right. So if x is less than or equal to negative 6, where the number is less than negative 6, to the left. X is greater than or equal to 2, where the number is greater than 2, to the right. Right. And does our graph, does it make sense with the type of problem? Yes, it does. Remember, if it's an OR problem, it's a disjunction. Disjunctions go away from each other, or both arrows are going to go in the same direction. Right? So our answer at least makes sense. That's kind of a nice way to double check. Alright, same thing. Now remember, like before, we have to get the absolute value part by itself first before we split up the problem. So let's add 9 on both sides. So we get 3, absolute value 2x plus 6 is less than 24. Divide both sides by 3. So we get the absolute value of 2x plus 6 is less than 8. Now that this is by itself, now we want to split them up. Alright, so let's split it up. The first one is going to be the exact same thing without the absolute value bars. 2x plus 6 is less than 8. Now remember, since it's a less than problem, if it's less than, alright, it's going to be and, because we know it's a conjunction. Then whatever's in here stays the same. 2x plus 6. What do? We flip the arrow. Make the 8 negative. Right. Minus 6 on both sides. So we're going to get 2x is less than 2. Divide by 2. X is less than 1. Minus 6. 2x is greater than negative 14. Divide by 2. X is greater than negative 7. And then let's graph it. So we've got 1 and negative 7. So let's say here's 0, here's 1, here's negative 7. Right, what kind of bubbles we're going to have? So at 1, there's no line underneath, so it stays open. At negative 7, there's no line underneath, so it stays open. Now if x is less than 1, or the number is less than 1, to the left. If x is greater than negative 7, where the number is greater than negative 7, to the right. Now you notice it was a AND problem, right? So it's a conjunction, and our answers connect. So we know that we probably did the problem correct.